if you talk about the technological advancements in the area of information technology, primarily the entire technology evolution has been around the data. Even when the information technology, the computer systems were introduced in businesses, the primary objective was to somehow store the data in an effective manner where it can be stored properly, and whenever it was desired, it can be retrieved, it can be modified, it can be updated in best possible manner. So that the accuracy, the availability of data on time, when it is required, could be ensured. And that's how the technology had started evolving. If you see, 1950 generally, in fact, it is very difficult to find out the deadline when actually, the timeline actually when computer systems were introduced in businesses. But there is a common consensus that that 1950, the early 50 was the era when people started thinking about introducing this computer system into businesses. And the objective was the computer systems were known for its accuracy in computation, efficient storage, as per the requirement which was there during that time period. And businesses have voluminous data, the large amount of data which was kept here and there, because if you see the 50s, the timeline when these computer systems were introduced, the industry was primarily manufacturing based, localized, and amount of data was not much as today it is. But the accurate calculation, the timely availability of information was the key. And that's how people started thinking, if we can use these computer systems to store the data, to manipulate it in a faster pace with high degree of accuracy, and that calculated value can be made available to the management for day-to-day monitoring of the business. That's how the system started. And that's why when we see the early implementation of computers, it talks about MIs kind of thing, where generally there's a prefixed format of reports were prepared, and then after computation, after manipulation, after performing the processing, the result which used to be produced was desired to be placed in appropriate column, which can be presented to the management, and they could take decision as per the requirement. But when computer systems are introduced, very soon people realize that these computer systems are not merely useful only for computation purpose, but also this can fulfill our other requirements too. And so, the quest for using these computer systems into more business functions was thought of. So what actually happened here? Now, primarily the data was there. That data needs to be stored somewhere, needs to be processed, computed, and that computed value needs to be presented in time when it is available. But when amount of data, that volume of data was very small, we could store on magnetic tapes. But you all know when we talk about magnetic tapes, about a magnetic tape of size around 100 feet magnetic tape could store around 500 MB data. And as the systems, as the businesses started expanding, naturally the number of customers, the number of people working in the organization started increasing. And that increase in the volume of data gave a force to the businesses to think about certain mechanism where comparatively large volume data could be stored and processed effectively, efficiently. And that's where people started thinking about centralized systems, and the concept of database was introduced. Now, when concept of database was introduced, this was a dedicated application which helped the organization to store their data in a central place. But the moment you start thinking about centralizing the data, ultimately that data has to be used by someone. Now, if someone has to use, so what option here is either he comes to the machine where actually the data is kept and use it. But when this data is going to be accessed by many people, will it be a viable proposition? No. So what our other option is? The other option is to ensure that this data is kept at a central place, so that at the same time different people from different locations could access it. And the moment you think you start thinking on these lines, there's a need to extend the accessibility of data from that central location where it is kept to the people, to the person who wants to access it. And the moment this requirement comes, you need certain kind of mechanism which would connect that central machine where data is kept to the users. And that's how the concept of network, the need of networks were felt. Now, over the period from databases to once that the size of databases started increasing, people started finding it difficult to the poor response time. And if response time is not good, it means data access is not efficient. And if it is not efficient, the productivity may not be as desired. So people started thinking for how to tackle this increase in data systems, databases. And that's where people thought that while a careful assessment and review of database systems, people realized that if we classify that data which is kept into databases, it can be categorized into two categories. The first category is the data actually system accesses for its immediate processing. And the second, that a fair amount of data available in databases which is not of current use, and rather the data life of the data has expired. So people started thinking on the life of the data system, so that as long as the data life is not expired, it is kept into database, and the moment the life expires, when the data is not of current use, we could think of doing something alternative. And that's where the concept of warehouse evolved. From databases, if life of data is complete, we can't simply discard the data, we can't simply remove the data, because that data can be very useful for predictions, for the futuristic decisions where you need it, actually the historical data. And that's how the concept of warehousing started, where people thought that let's segregate the data, the current data and the historical data. The current data will remain in the database so that it is available to the system for processing, and the data which is not of current use but historical in nature, it should be taken out from here so that that volume is maintained balanced. And that historical data was taken out and stored into the warehouses. Now, in warehouse, generally you take data from database and dump it there. So normally you will find the data which is transferred into the warehouses is not removed. It is not deleted. And if it is not deleted, you will appreciate that after over a period of time, the amount of data which is increasing exponentially, our conventional algorithms may not be appropriate, may not be able to cope up with this increasing volume. And because of this restriction of algorithms, that linear search, binary search, whatever searching mechanism we use, then it is found that if the size of or volume of your database increases beyond 100 gigabyte, these algorithms find it difficult to cope up with this. And that's why the databases, where normally we use these searching algorithms which we have, and the warehouses cannot be accessed. The efficiency cannot be maintained if you go with the conventional and these linear search, binary search, or these kind of algorithms. So people start thinking that different kind of algorithm altogether, which can be executed on the warehouse. And please note this, the objective of data warehouse is not in quick decisions. The objective is we have historical data, and can we find out certain novice patterns which we could take, and after analysis, if it can be of any use in our futuristic decision, we can use it in formulating the strategies for futures. So that efficiency is not of that importance, rather than that creation of those patterns. And those patterns are in any case there. But we need an algorithm which is intelligent enough, which processes the data, analyzes it, tries to find out the pattern, then find out the correlation between the patterns, and if there is an interesting pattern consistently exists, it suggests us that this is the kind of pattern which is in existence, and then after careful study and analysis of that particular pattern, if it can be used in some futuristic decision, you take it. So that normal algorithms are of no use at all. So that's all that is specialized algorithm where data, that volume of data is there, and you try to mine it, dig down. And after mining, you try to find out novice pattern. The first condition is you try to find out novice pattern, and those novice patterns can guide you to take decisions which can help you in making futuristic decisions. And your futuristic decisions you are taking, the level of confidence is very much important. Because if your predictions, because when you say futuristic decision, it is in fact you are trying to predict something. And accuracy of prediction, that confidence in the level of predictions you are making, ultimately organization is going to either benefit it or suffer a lot. So that analysis has to be done very careful. So the number of approaches which use a combination of different algorithms, like when you talk about data mining algorithms, it talks about uses of artificial intelligence, neural networks, nearest neighbor approach, and the number of approaches which generally you use. So, but till this point, from databases to data warehouses, data has been extracted from somewhere, it is stored there and processed as per requirement. Current data, it is accessed by the current system, and from there decision is making for day-to-day operation. Historical data which is kept in warehouse, you process it, you analyze it, and then you take futuristic decisions. But one thing is common, that the data which you are going to is stored either in databases or in warehouse. This is structured in nature. When you store data in table, you form a structure, like if you are storing data of employee, you write employee ID, employee name, his designation, his department, his contact number, email ID, and so on and so forth. So what you are in fact creating a structure of data, and then within that structure your data is stored. And in tables generally it's a two-dimensional object. So when you say table, and then one term is a relation. In fact, if you talk about a relation, what is the difference between a table and a relation? When you talk about a table, generally you name it. But when you talk about a relation, that relation is an abstraction, a generic term. You don't name a relation. The moment you tag a name to the relation, it becomes a table. So whether it is a table, whether it is a database or warehouse, in both the cases, data is stored in the form, only the structured form. In tables, that is two-dimensional, and when you go to warehouse, you realize, you experience multi-dimensional structure by just combining the table, which are basically a two-dimensional object. So how do you create a fact table? Generally, a fact table contains the primary key of the rest of all the tables, and then, like if you have a fact table where you store employee table, the primary key of employee table, primary key of product table, and XYZ, then this primary key of employee table is in fact table, and the rest of the details of employee are kept in employee table. So that employee table becomes a dimension, and the table which is storing the primary key of this becomes the fact table. So fact table and dimension table, these two are two-dimensional tables, but combining these two, you realize the multi-dimensional structure. So one thing is common, that in both the cases, the table which you are going to store is two-dimensional object. But now the biggest challenge is, you have got with the emergence of social media, whether it is a Twitter or it is a Facebook or it is LinkedIn, or other social media platforms, where millions, billions of people, like Facebook itself in September 2017, that data which was released, it 2.6 billion people are connected on Facebook. Around 467 million people are on LinkedIn, and likewise on Twitter, 360 million odd people are on Twitter. That Twitter account, that monthly active users are 360 million already. Now, if this much amount of users is available on these media, and they continuously keep posting, keep commenting, keep liking the contents, you can, if you have a proper mechanism, it is very easy to track the users, that what kind of objects, what kind of contents they prefer, and then accordingly businesses may take decisions to take the information of their products or service or facility, whatever they are offering, to the appropriate people. So you just can't ignore 2.6 billion people who are on Facebook. So the data which is generated by the Facebook, and by the way, Facebook generates every day 500 terabyte data. That amount of data which is being generated, it can't be ignored. But your database or data warehouse, they do not allow you to store this data, which is not structured at all. Because if you're writing a comment on Facebook post or Facebook wall, you don't follow any structure. You simply write something, whatever you want. So that expressed information is not structured, but still of very much useful. So how to store this? Now you can't store in a table. That's where the need of an alternative which could help you in storing this unstructured data also is very much important. And this need has given birth to now the dominant dictator of the era, which is big data. So essence of big data is not basically the volume. The essence of big data is to help you in storing the data irrespective of its type. And that's why the definition of big data includes 3 V's. The volume, in any case, data has to be there. The volume will be there. So volume is one. But the most importantly is the variety. The kind of data which you are able to store in big data. The different variety, whether it is structured or semi-structured, because sometimes you also use certain kind of the data which is not basically structured, but are using tags like XML document you create. You can still use it like structured, so semi-structured that is. So this big data allows you to store variety of data, whether it's structured, unstructured, or semi-structured. And then comes velocity, because data changes very fast. Now, gone are those days when we used to store data, and data used to kept static for quite some time. But not today. The data is changing so frequently that it is on a faster pace where it is becoming very difficult to cope up if you don't have appropriate system with you. So, these triple V's, velocity, variety, and volume, basically they are the defining characteristics of big data. We will be taking this concept of big data in the next session. I'm sure that this fundamental orientation of this subject, what we have undertaken today, we will continue in separate different sessions. There will be different sessions we will be having, and it may last maybe 4, 5, 6 modules. So in any case, I will let you know when we will be ready with the next session, and I'm sure that together we will be able to create a learning mechanism where we together share our own understanding, our own exploration, and at the same time we keep our knowledge base enriching. Thank you so much.